In recent years, our planet's climate has changed drastically, affecting the length of rainy seasons and our water reserves. With this change, here in Spain, as in many other countries around the world, new measures have been taken to restrict the use of drinking water due to an alarming low level of water reservoirs. Aware of this critical problem, we have asked to ourselves, our consumption habits are the right ones? Of course we pay our water services, but do we know if we waste water on our daily routines? How can we change our habits? Conscient about this problem, we have designed an IoT solution that we call it Aquaminder. This IoT will contribute to become us more aware about our water consumed in our home. This IoT is confirmed by a sensor installed in the faucet we want to monitor, that at the same time it's connected to an electronic circuit which shares data monitored to the Arduino cloud. With all this, the Aquaminder helps us to contribute in a better water usage and less waste. For the Aquaminder flows sensor, we took our previous experience in hydraulic electronics, and we have designed a flowmeter sensor based on a magnetic turbine that it conforms by a body which includes a small helix turbine. The helix has a magnet that spins with the input of the water flow and triggers a magnetic switch. With every spin, this magnetic switch is activating, giving us a pulse per each complete spin of the helix. As for the circuit, we have used mainly an Arduino Nano 33 IoT to later connect it to Arduino Cloud. We have also included an 0.91 inches display to show available status and data from the measuring, and we design all with the magnetic switch read as an input. We thought about this IoT as an autonomous IoT battery powered, so we have a rechargeable circuit with a 3.7 volts battery. We can see some protoboard drive testing. With every spin of our helix, it triggers the small LED, showing us that it can easily capture the frequency at which the magnetic switch triggers. We installed in our bathroom's faucet a protoboard circuit, firstly to obtain the max frequency we can read at maximum flow. Then we compute with the real flow the equivalence in liters per minute, and we approximate a K factor, which is the correlation of hertz in frequency to liters per minute. With all this, we estimate for the period of time the measure lasts with the total volume of water we spend. Once we have all the calculations done, we have done an improvement. We designed first from our circuit an enclosing to protect it and to help us to be installed in our bathrooms or in our home. We upgrade our circuit to a PCB, we wire all together, and we put it in the enclosing and close it. At the end, the final assembly of the Aquaminder, it is like this. It includes the enclosing of the circuit with the electronics and the connection to the Arduino cloud, and the body and the helix for the turbine. We can see at left some dry testing connections to the Arduino cloud, capturing the frequencies of the turbine, and at the right we can see a video where it's installed and already triggered by the water of the faucet on our button altogether. For the cloud, we have defined some global variables that we connect to our dashboard of Aquaminder. With this, we were able to perform a web dashboard that allows us to connect our Arduino Nano with the Arduino cloud. From these variables, we have the connected status as Boolean, the water consumed as a Gauss widget, showing us in liters our consumption, and at the same time with a chart for historical proposals, a reset total switch button to restart the count of liters anytime we want, and finally a trigger of reading status in case we are out for vacations. Once we have done our first deployment, we attach more widgets, such as a timer to keep in mind the date we are capturing, and we can see the chart capturing the measurement of total liters we are spending. Maybe it's hard to imagine 1 or several liters of water that we spend, but maybe as glasses it will be a good exercise. For each liter we have more or less 4 glasses of water approximately, and during my testing, in just the faucet of my bathroom I used 3 glasses of water just to washing my hands and brushing my teeth. So how many glasses we spend every day? Do you know? Do we need all the water that we spend? Let's be more aquamindfulness aware of our waste with the help of Aquaminder, because every drop counts. Thanks for watching.